All right, so how would we do this one? This is like the one we left off with yesterday. It says solve this equation. They give us a cubic equation given that -1 is a zero of the function. So that's a solution of this equation. It's where the polynomial is equal to 0. Okay? So what can we do? If we know that -1 is 1, 0, how am I going to find the others? I can. I can do synthetic division, right? Because I know that if I want to find the other factors, I've got to divide this polynomial by x plus 1, don't I? Right? Because the 0, if -1 is a 0, doesn't that mean that x plus 1 is a factor? Right? And so we know that x plus 1 times something, right, is going to equal this whole big thing. Right? So we could just divide divide both sides by x plus 1. So those guys cancel, and that'll tell me the other, the other factor that's multiplied by x plus 1. Okay? We can do that synthetically. That's no big deal. We can do that synthetically. So we get my coefficients are just 1, -5, 2, and 8. What's guaranteed to go in the remainder box? 0. Yeah, because they're telling us, I'm going to put a -1 out front, right? And they tell us that -1 is a 0, right? So there's no remainder then, okay? So we just do this synthetically. Bring the 1 down 1 times. Bring the 1 down 1 times -1 is -1. Plus -5 is -6. -1 times -6 is 6. Plus 2 is 8. Times -1 is -8. And sure enough, it works, right? So then what is this telling me? What's the other factor then? What's this mean? Those are the coefficients, right? That's the wimpiest coefficient, so that's the constant. That's the coefficient of x to the 1. That's the coefficient of x to the 2, etc., right? So this is telling us then that we get x squared minus 6x plus 8. So that's what goes there. In other words, we now know that my original 0 they gave me was -1. That's the 0 of that factor. That times x squared minus 6x plus 8 is equal to 0. Because now we've got the original polynomial factored, right? Can we go further? Can we factor the green even further? What are the magic numbers? -4 and -2, yeah. So now we know we've got x plus 1 times x minus 4 times x minus 2 equals 0. Okay, what are our zeros? Well, that one we already knew. They gave us -1, right? But these are the ones we didn't know. X equals 4, x equals 2. Okay? Did we have to write that whole thing down? No, not really. I mean, we could have just, we know that if -1 is a 0, just divide it into the original and factor what's left over. And that's all you really have to do there, right? We didn't have to write all that stuff down. I wrote it down just to provide some context so you guys would see, kind of remind you why we're doing this. Okay, give me thumbs on that. Okay? All right. Okay, what about this? So this is kind of a bonus question on the test. It's only worth like 1 or 2 points. But I want to show you what you do with one like this. Now, if we're supposed to, this is the question. So they give us this big polynomial, and they tell us that negative 3/2 is a 0 of f of x. Okay? We want to find the other solutions, the other zeros of this function, given that. Okay? Well, let's try something. Just to build up to that, let's do a little warm-up problem. What if I said build a polynomial with zeros x equals negative 3/4 and x equals 1? Okay? What's the factor that's going to go with this 0? If x equals 1 is a factor, is a 0, what's the factor that goes with that? X minus 1. Good, right? Make sense? Okay, so what about this one then? If x equals negative 3/4 is a 0, what's the factor? X. Okay, yeah, so it's like x plus 3/4, but that's kind of an awkward factor. What could we do to that one? Carson? Yeah, we could clear the fractions, right? Instead, we would write that as, now where would that come from? That would come, if we kind of reverse engineer this, right? If we found out that x equals negative 3/4, let's just start there. If x equals negative 3/4, if I add 3/4 to both sides, I get x plus 3/4 equals 0. What would the prior step have been? Prior step would have probably been to, what would we have done? We would have, let me do one thing differently. One thing differently. This will be good. What would I do here? I could clear the fractions and get 4x equals negative 3. If I add the 3 to this side, don't I get 4x plus 3 equals 0? Aren't those the steps you would have taken in reverse to find the 0 of that factor? Right? We would have subtracted the 3 to the other side and then divided by 4. So if we reverse all those steps, we end up with the factor 4x plus 3 instead of the factor x plus 3/4. We don't want to have a fraction in there, right? We want to write this with integer coefficients if we can, and we can. Just by multiplying through, that would be equal to 0. If I multiply each side by 4, I get 4x plus 3, which is much more convenient. So my factors then would be x minus 1 and 4x plus 3. Those are my factors, right? Okay, so now with that line of thinking, what's going to be, you guys tell me, if negative 3/2 is a 0, what's the factor that goes with that? Yeah, it'd be 2x plus 3, wouldn't it? Right? If we work backwards and say x equals negative 3/2, 2x equals negative 3, 2x plus 3 equals 0. Well, that's my factor, isn't it? Right there. Everybody get that? Okay. So if 2x plus 3 is my factor, then what would I do? Instead of dividing through synthetically, I would just divide through using long division. Okay, does that make sense? Everybody good with that? Okay. So to find the rest of these guys, I would just take this. I would take this, and that's what goes inside the division bracket. There is a way to do this with synthetic division, but I don't want to throw it at you now. I feel like that's just too much, too late. It's, well, if you don't talk about it next year, we'll talk about it in calculus as seniors. So we'll just divide that out, right? And what's that going to give me? If I divide that out, we can do this really quickly. 2x times what is 12x cubed? What? 2x times what is 12x cubed? 6x squared. Agreed? Okay, so I distribute. 6x squared times 2x is 12x cubed. 6x squared times 3 is plus 18x squared. I subtract vertically, so those cancel. 16x squared minus 18x squared is negative 2x squared. Bring down the rest. Go again. 2x times what is negative 2x squared? Negative 2x, okay. So I distribute negative 2x times, oh, sorry, negative x you said, right? Not negative 2x. Negative x times 2x is negative 2x squared. Negative x times 3 is minus 3x. We'll subtract the whole thing, so those guys cancel. Negative 5x minus negative 3x is negative 2x, right? Bring down the minus 3. Or 2x times what is negative 2x? Negative 1, right? Multiply the negative 1. Negative 1 times 2x is negative 2x. Negative 1 times 3 is negative 3. And what do you know? When I subtract this whole thing, I end up getting no remainder this time. Okay? 0 remainder. So my answer is just 6x squared minus x minus 1. Okay? Did they want us to, oh, they want us to solve it. Sorry. So then we would set that equal to 0 and solve, right? That's the other factor. Everybody get that? Okay, so in other words, the blue is being replaced by the factors. This is going to become 2x plus 3 times 6x squared minus x minus 1, and the whole thing is equal to 0. I already know this solution is negative 3/2. I just have to find the other two from that quadratic factor. What would you do? How would you find the zeros of that quadratic factor? Say it again. The quadratic formula probably, right? It might factor, multiply negative. It does factor if you use, but maybe it's not worth the hassle of factoring. It's up to you. It actually will. But you could also just set it equal to 0 and solve with the quadratic formula to get the other two. Okay, make sense? So that one's kind of a bonus. That's a tougher problem. I'll give you that. It's only worth, like I say, a point or two on the test. Okay, these, really quick. So solve the system of equations. How would we solve this one? By substitution, right? Both of them are already solved for y. So I could take that top equation, for example, and substitute the trinomial in for y in the bottom equation. And what's that give me if I do that? I get x squared plus 8x plus 5 equals, on the other side, negative x squared plus 4x plus 11. I'll just push everything over to the left side, won't I? So I get a positive number of x squareds. Okay, if I do that, I'm going to add x squared to both sides. I'm going to subtract 4x, and I'm going to subtract 11. So we get 2x squared plus 4x minus 6 equals 0. Okay? So far, so good? Right? So this is going to allow me to solve for x. I could factor out a 2, leaving me x squared plus 2x minus 3 equals 0. I could even divide each side by 2 and get rid of that 2 now if I want to. Don't have to. And then this is going to split up. I can find magic numbers. What would they be? X plus 3, x minus 1. Everybody agree? Did I do that right? So my solutions then, well, at least part of my solutions, either x equals negative 3 or x equals 1. But we're solving a system. So that's only half of each ordered pair. I need y values to go with those, right? So we could take the x equals negative 3 solution, for example, and plug that in. So we got negative 3. The other one was 1. And just plug those in to one of the two equations. Let's use the top one. if I plug negative 3 in for x, what do I get? Well, y equals negative 3 squared plus 8 times negative 3 plus 5. So y is negative 10. So one ordered pair, one solution is negative 3, negative 10. The other one would be when x is 1. When x is 1, y equals 1 squared plus 8 times 1 plus 5, which is 14. Okay, so those would be my two solutions. Good? Give me 1 to 5. Does that make sense?
Wait a second while I write that down.
Okay. Right? So to me, these would be, like on the test, these are probably two of the easier problems on the test. There's really not much to it. You're just substituting, solving for one variable, plugging in to find the other variable. Okay? Or you could get one like, are you good, Monica? Or you could get one like this, where substitutions is a bad idea, where it's really hard to isolate a variable, but I could use elimination, couldn't I? I don't even really have to do anything fancy here. I don't have to multiply top and bottom by anything. If I just add these equations up right now, look what happens. The y's are going to cancel, aren't they? Right? So I would just get 2x squared equals 32. Solve for x. X squared equals 16, so x equals plus or minus 4. Now I just have to try both of those. Okay, so if we take x equals 4, or x equals negative 4, and see what happens. And we'll just plug into, how about if we just plug into the top equation? If x equals 4, that top equation is going to become 4 squared, so 16 plus y squared equals 65. Just solve for y. Subtract 16. Y squared equals 49. So what are the solutions for y then? Positive or negative 7. So what's that tell us then? That tells us that when x is 4, y could equal 7, or y could equal negative 7. I actually get two ordered pairs out of that, right? Everybody see that? Same thing for the green. Look what's going to happen here. If I plug negative 4 into that equation, look what happens. Negative 4 squared is 16 plus y squared equals 65. Does that look familiar? That's the same thing we got over here, isn't it? Right? So I know, you think the solutions are going to be different because I'm doing it in green? I don't think so. I think I'm going to get the same solutions. So I get y equals plus or minus 7 again. And now what would my other two ordered pairs be? Yeah, good. Negative 4, positive 7, or negative 4, negative 7. So I actually get 4 solutions to that system. Okay? Good? All right. That's it. So I'm done. You guys can test today. I'll give you multiple retakes, just so if you want to just try the test today instead, you're welcome to. If you don't like it, no big deal.